Hello, Algebra class. We are ready to start Chapter 10, Section 1. In this lesson, we are going to be learning about square root functions. So first, a square root function contains the square root of a variable. So any function that has a square root is called a radical function. You'll remember that a square root, the formal name for square root is radical. So square root functions take the square root of a variable. They're also known as radical functions. The radicand is the number under the square root symbol. So if I say the square root of x, that's a square root function, and x is the radicand. Alright, here is the parent graph for any square root function, f of x, such that you're taking the square root of x. And this is what the parent graph looks like. So every graph will be a transformation of this graph. And we can remember from our previous chapter that plus c will tell us how it moves up or down on the y-axis. The plus h will tell us left or right, and remember this is the one that's backwards. Plus h actually means to the left, and minus h actually means to the right. And then the a tells us whether it is stretched or compressed. And if a is a negative, that means a is less than 0, the graph is reflected across the x-axis, or it will be in quadrant 4 instead of quadrant 1. So let's look at some graphs on the next page. The parent graph is y equals the square root of x. A reflection looks like this, so y equals negative square root of x just means that it was reflected over the x-axis. The blue translation moved up 3, so it moved up. So the new formula, or equation rather, is plus 3. This one moved down, so our equation would be y equals the square root of x minus 1, 2, 3, I believe. It's hard to see on this little bitty graph. The purple one went to the left, so it translated left. Now remember, this is underneath the radical, so it's x plus 3 because to the left is the opposite of what we think it should be. And this one moved to the right, translated to the right, so it's y equals the square root of x minus 3. Then we have one that is stretched. See how it got bigger? So we'll say a vertical stretch. So how did it stretch? We've not talked about how to determine how it was stretched. I'm going to tell you that it was 3 because everything we've done so far was up or down 3, left or right 3, but we really haven't talked about how to determine it was 3. And this one was compressed, and it would be then 1/3. But again, I do not expect you to know how much it was compressed because you really, we don't have enough information to determine that. If we are asked to graph a radical function, we already know that it's going to be compressed. This tells me compressed, and that is the only thing that's going to change. So to graph it, we will need to take these x values, these domain values, to make our table. So half of the square root of 0, which would be half of 0 is 0. Half of the square root of 1 would be 1/2. Half of the square root of 2, which you would need to use your calculator, is about 1.4, and then take half of that. So in a decimal answer, it's 0.707. Half of the square root of 3 would be another decimal answer of 0.86. Half of the square root of 4 is half of 2, which is 1, and then half of the square root of 5, which is 1.11. Now we are ready to graph. And it's going to be tedious, but we're going to move from 0, 0, then we had 1 and 1/2. 2 gave us 0.7, so a little bit more than half. 3 gave us even more than that, but not quite to 1. And then the square root of 4 gave us 1. And then the square root of 5 gave us 1.1. So it's a very tiny curve like this. and it is compressed. The domain would be x such that x is greater than 0 or equal to 0, because we did have 0, 0, and the range is y such that y is greater than or equal to 0. It's all going to be positive numbers for our domain and range. All right, number 2, to graph, we know it's stretched and we know it's moved to the right 2. So we can make a table real quick for x and y, plugging in, let's do 2, because 2 minus 2 is 0. Start with 2, 2, 3, 4, 6. So 3, 2 minus 2 is 0, gives us 0. So this is actually going to be my y. This is going to be my function. 3 minus 2 is 1, so that's 3. 3 times 4 minus 2 is going to give me a decimal of about 4.2, because the square root of 2 times 3 is about 4.2. And then for 6, I picked 6, I skipped 5 so that I'd have an even number. The square root of 4 is 2, and 2 times 3 gives us 6. So now we're ready to graph. I'll use a new color. So we shifted 2 to 0. Then at 3, we were up to 1, 2, 3. See how it got stretched? At 4, we were at 1, 2, 3, 4.2. And then over at 6, we went all the way up to 6. So you can see a distinct difference between the two graphs, one being compressed, one being stretched, one staying at the origin, the other one being shifted to the right 2. All right, that is graphing radical functions. Please go ahead and do these next two on your own. You should know what your graph's going to do before you actually start graphing it, and practice stating the domain and range. Then we will get into the real world examples in class tomorrow. So have a great day. Thank you.